Good morning, everyone. Welcome to NLIT 2020, and thank you for tuning in to the talk titled Leveraging Pentaho for Practical and Strategic Intelligence in the context of scientific machine learning. My name is Pragyan Nayak, and I function as the Chief Data Scientist with Hitachi Vantara Federal. I have been with Hitachi for about 2 years and with overall 20 plus years of experience in software development and data science. My exposure to machine learning and artificial intelligence began as part of my PhD journey, where it involved applying machine learning algorithms to estimate the distances of galaxies. I'm active in the data community DC, as well as I have participated in multiple talks related to data in the past, as well as I function or volunteer as reviewer for several data related conferences. For Q&A related to this talk, please visit the virtual booth of Hitachi Vantara Federal. So let's begin with what I mean by scientific machine learning. This definition is definitely taken from the basic research needs for scientific machine learning research paper, where it outlined it in the most direct way as possible, saying that this will have broad use and transformative effects across the Department of Energy. And they outlined 6 priority research directions or PRDs in developing greater SciML-based capabilities for DOE mission challenges, namely in the space of being the machine learnings being domain aware, interpretable, robust, data intensive, machine learning enhanced modeling and simulation, and intelligent automation and decision support. There was one example which stood out. It was in the space of network forensics, and it dealt with optimizing network traffic with machine learning. So this talk will try to tie together the products that I typically work with as part of our various projects and tie it together to the network forensics aspect. So why do we essentially do these type of predictive analytics? We are trying to get some actionable analytics. Certain decisions need to be made, and these decisions are better made, more well informed. That is based on certain intelligence, based on certain smart data. And the overall goal is to have operational efficiency or have certain data monetization opportunities. Now, let's tie it back together to our systems thinking, which ties together the vision and mission of an organization or a project or any effort that is being undertaken. There has to be a vision or a mission associated with it, and then that ties down, that gets broadened out into the goals and objectives, strategies, and tactics. Now, these all are intertwined in some way or the other. Where are we going? That is typically the strategic goal. And what do we do to get there? It's more tactical and operational. What are the tools and the people who are going to enable us to get to that vision and mission which we have envisioned or have dreamt of for an effort that we are undertaking? And this results in certain action items. And as part of a data-driven initiative, we would like those action items to be data-driven. And what happens in that process is you would like to have a real-time picture of or real-time understanding of what is happening versus big picture. And they both kind of lead to our tactical and strategic goals respectively. Tactical goals give us a pulse on the present, while strategic goals are more emerging trends and patterns. They while one is more granular in the sense it's looking at current operations and corrective measures to stay in course to meet the vision and mission, whereas strategic goals are initiatives to push boundaries and measure the success in meeting that goals over time, keeping track that how far along have we gotten, are we there, what should we do to in order to, if we have diverged from our strategic goal, what tactical corrective measures do we need to take so that we come back on course or we stay on course? So as you can see, there will be specialists who will require highest granularity of the data versus generalists who require summary of the data, hitting the key metrics. Now, one tactical goals is typically in the space of notifications and alerts, where strategic goals are more in the widescreen, the big picture view of dashboards. Now, there'll often be cases where it'll be fuzzy as to it can be an overlap, but if you want to get a clear demarcation between your tactical and strategic goals, this is typically the distinguishing factors. And we, we can enable applications in both these spaces using some of our data products. And I'll be going a little bit further into that to give you a better idea on how both these goals can be accomplished. Now, apart from tactical and strategic goals, there are certain other reasons why a particular organization or a project gets data driven. That is in the federal government space, that's typically when we have to have certain regulatory compliance. That can be in the space of data protection and digital privacy, or in the space of cybersecurity constraints that we have, so that there is continuous diagnostic and mitigation happening whenever there is a breach of cybersecurity or data related act that is interesting is the GREAT Act, which the acronym stands for Grant Reporting Efficiency and Agreements Transparency. All these lead in the direction of the open data effort. Open, as the word says, it means making the data more easily accessible and usable. But in turn, it's an acronym as well, which stands for open, public, electronic, and necessary. The electronic is key because what it is trying to get at is if you're generating data and making the data accessible to the citizens and outside your agency, ensure that the data is electronically possible so that there can be as much automation done with using that data as much as possible. Now, there are certain data sites which I have mentioned here, which will give you more easy access to federal government related data and associated activities. I'll definitely encourage you to also check out this executive order, which is in the direction of maintaining American leadership in artificial intelligence space. Now let's move on to the platform that I mentioned we typically use for these types of tactical and strategic goal related projects. The platform's name is Pentaho. What it essentially lets you accomplish is that you can ingest data from a wide variety of data source technologies. Now that is not a unique problem in some spaces. It's typically occurs in most agencies where you have data being collected in various formats, or in your scientific machine learning domain where you're trying to maximize the amount of usable data or the different types of data that is available and get them working together to accomplish the research objective that you have in mind. And as we all know, each technology which generates data has its own unique intricacies and complexity associated with it, which makes it difficult for us to work on all these different data together. So this platform helps bridge that gap where it enables you to get the data connected to these different platforms or technologies which are generating data, get them to a common platform, and then work on the data together in a clean format, in a succinct format, so that it is just enough. Whatever your problem or research statement requires you to work on, you can reduce the scope of the data to that and then work on that data so that the whole solution is more performant and you can work with more amount of data as well. Now, the types of data that you can connect to is both in the big data space as well as in the traditional data. So you would take that in, you would do the necessary manipulation, transformation that is required, any type of cleanup, any type of reduction of the data, as well as generating new types of data, maybe combining 2 or 3 different types of data and creating a new metric, things of that nature. That Pentaho makes it very easy to perform those type of data transformations. And then you can make the data into a format in a database or any other resulting data technology so that that data can be worked on using a downstream technology. For example, if you're trying to visualizing the data, there is the Pentaho Business Analytics platform, as well as if you want to use your R or Python scripting to be able to look at the finalized or the cleaned up data that you have, that's also possible. This lets you perform descriptive, diagnostic, and further predictive or and prescriptive analytics downstream. It's a flexible and an open architecture, and it works, as I already mentioned, seamlessly with other analytics and visualization platforms which have any type of REST API or other type of common data connection mechanisms available to it. We'll look at a couple of examples just to give you more insight into the data visualization capabilities as you are doing your data analysis to look at the data from different perspectives. So the first example I'm outlining here is the US Coast Guard data, which involves the data from United States and its territories, and it shows data related to marine casualty investigations. And there are these couple different types of concepts within that data set that you can work with and try to get a better understanding of these different casualties which have occurred. So first, Pentaho involves a particular component called the PDI, which stands for Pentaho Data Integration. That is the one which lets you do your feature engineering, data fusion, all that data manipulation that you want to do before you can do any visualization with it. And then you could potentially do these type of mapping within the Pentaho Business Analytics application. And as I mentioned, it's also a low code platform. That is, as you can see, it's like a flow based programming. So it makes it easy for both programmers as well as non-programmers to work with the product and get what they want to accomplish, what they're trying to get at. So it's a visual approach to software development, which makes it much more easier to work with. There's certain other um, perspectives of the data that we had taken a look at. I'm only showing a couple of them. If you're interested, we can have a one-on-one discussion and get into more details on all the different what if analysis we had done and different attributes exploration that we did related to this data set, as well as the next few examples. So as you can see, this one is looking at a how many of these facilities that were mentioned in this data set related to the US Coast Guard, how many of those are active, how many of those are inactive, and the proportion of the different facility types where incidents have occurred. Then it's also looking at the further breakdown by the state. Another There are three more examples that I want to quickly cover just to show the different types of analytics problems and the different types of spaces in which it has already been applied, and which kind of gives you an idea as to if you have data, then this platform will be a good tool to evaluate and see if it applies for your specific problem, and to be able to do these type of initial exploration, or as I would call these type of visualizations as descriptive and diagnostic analysis before you get into the next step of doing any type of predictive and prescriptive analytics. So this was looking at the storage analytics, like uh, there are certain, we have a product called HCP Anywhere, which is a file sync and share platform. And we were looking at how many users are using it, as well as how much are they using and who is using it more, and of the available storage space, how much space is still available, how much is used. So all that neat analytics is being done as part of this type of dashboarding. Third one is looking at the US economic census. So here we were looking at the data made available via data.gov and looking at these different types of business establishments, their distribution across the nation, as well as state-wise, as well as what are their taxation structure and things of that nature. This fourth example I want to highlight is because this shows an example where the data is taken and then it's not just processed via Pentaho, but also via another platform. And in this case, it is the Elasticsearch stack. And what we have done here is we took the data from the Consumer Financial Protection Bureau. The data is made available in both CSV as well as JSON. So we took that data, then we did certain cleanup, and then we made it available in both Elasticsearch as well as a PostgreSQL database, which is a relational database, as well as S3. So you can see like it makes your data streaming and data manipulation much more streamlined and easier to handle and update in future as well. So this was a way because we were looking at certain textual data. So it was important for us to have a a analytics application which was more tuned for analyzing text-based data, this type of unstructured data, and Elasticsearch was more easy to work or more recommended for text type data type analytics, and we included that in the architecture over here. And then the resulting analytics and doing self-service analytics on the data which has been generated, and looking at the different states and what were the proportion of the different complaints, user complaints which have been filed at the Consumer Financial Protection Bureau, and what were the different categories and the number of complaints state-wise, and the further drill down to more details around the same. Now, that was all those examples were in the space of descriptive and diagnostic analytics. Let's move on and look at the predictive and prescriptive analytics, which is more in the space of what will happen, leveraging all the data that is available and utilizing them to better understand the patterns and trends, and being able to do the what if analysis for data which has not been seen, and being able to predict outcomes in the future as well. Now, machine learning, which is in the predictive analytics space, there are typically three different categorization of the algorithms which are used in machine learning. Supervised learning is a labeled data exploration, and this is in the classification or regression, where you have a certain label or a particular attribute that you want to get a better understanding of the patterns and trends associated with it. In unsupervised learning, you want a general characterization of the data. So you're trying to understand what are my demarcation in the data. And remember, this is like trying to simplify these. There are a lot more intricate details associated with each of these. In the most simplest term, unsupervised learning is when you're trying to do your, for example, clustering, you're trying to do some type of anomaly detection. And we will see that in the network forensics example that we want to highlight as part of this particular presentation. Reinforcement learning is the third category of machine learning, and that's typically in the space where there is a reward penalty framework, and you're trying to get an agent to learn behaviors and trying to make it move towards an optimum behavior or a more recommended behavior using this whole reward penalty framework. Now, machine learning solution formulation is typically involves these different steps. Like you define your problem, then you understand your data, you clean it, you do your data engineering around it, then you determine based on the problem you're trying to address, you determine the algorithm that makes most sense to apply there, and then you go through the cycle of training and validating that model using the algorithm that you chose, then defining the model for that, training the model for that, and then testing that the model behaves well with unseen data yet or not, and then deploying the model for to production use. And then the cycle repeats, where as more data is made available or a better understanding of your problem statement is derived, you would go back and further either repeat the training or do the incremental training based on what is available to you with respect to the particular algorithm and the frameworks that you have in place. Um, and then I want to just highlight that there is a Pentaho machine learning framework available, and there's certain algorithms, machine learning algorithms, which come inbuilt with that particular tool, and which you could use. Now, what this lets you do is this whole feedback process that I mentioned, that's kind of the MLOps, where there's a continuous delivery and automation of this machine learning lifecycle management, this whole model management, metadata management, etc. There are AutoML libraries available for that process, which lets you automate the process of feature engineering and the model selection as well, and being able to do the metadata management. Now let's look at the particular tool within the um, Pentaho marketplace that helps you address the machine learning is the plugin machine intelligence, or as the acronym code PMI. Now, let me also mention here that Pentaho has R and Python script executor steps. So if you already have certain R and Python scripts which you use to perform your machine learning processes, and even if those scripts are even non-machine learning related, you could use the R and Python script executor to get those script execution as part of your data manipulation and data transformation pipeline. Now, PMI supports training, evaluating, and scoring machine learning algorithms using these 5 main libraries. So, if you're already working using these libraries, then it's straightforward. Um, with every release, there are additional algorithms, there are additional libraries being added as support. If there's a certain library XYZ which comes into prominence in future, there's a very good chance that in the next Pentaho release, that library will be supported. So we're constantly updating that. And just to tie it together to the earlier slides, in the form of that there are data available, and then these data will be in the spaces of different types: structured, unstructured, or unstructured data. Then using Pentaho to ingest them, putting them in a central repository, and then further, if you want to do further any type of cleanup or manipulation before you use them, and then being able to use that cleaned up, finalized, your favorite data in an advanced AI and ML application. So again, I'll just stress, this is something I've already mentioned, that these PMI steps or the R and Python script executor steps just lets you do your machine learning or your data manipulation steps as part of the regular data transformation workflow. So there is not it is not a handoff which is happening between Pentaho and a different application, and then once you're done using that application you come back. That is not the way it is done. This is all part of the same workflow, so that makes it easy to, as part of your operational maintenance and keeping track of your executions as well. So this provides kind of a big data fabric and an analytic platform. And this has been used by the marine division of Caterpillar. They used it for two main problems actually. One was optimized hull cleaning. So the hulls get trapped with seaweed, etc. So figuring that out, and they used Pentaho for that purpose. Used Pentaho was in determining the power usage with respect to their generators. And as I was talking about the MLOps or the metadata management and the model management, you would use a process like this. It's a different layout from what I had shown before. So you get your data and you determine what is the model, machine learning model you want to use. You train, build, and test that model, and then you deploy it. And then after that, there is this constant cycle or the MLOps cycle where you are constantly measuring and tracking metrics related to your machine learning models, and then repeating the process on a frequent basis, or you determine a frequency, what is the most optimum frequency at which you should be doing it based on the characteristics you have seen, and then get that repeated improvement of your cycle in place. And this is the network forensics example that I want to highlight. It was for one of the federal government agencies where we took the packet capture data, and then they had additional applications where network related and system related data was being maintained. So we took those. These were either in the form of XML or JSON messages, or they were being tracked in a separate application which involved the Elastic Stack. So that data was made available to us as JSON and a REST API. Or there's a NetFlow application from SolarWinds where we could connect to the MS SQL server, which is the back end of the server, and then being able to use the REST API and JDBC to get that data. And then additional reference data which is available, and got them all together into a data lake. And then from there on, we were able to use ArcGIS and R scripting as well as the Pentaho Business Analytics to be able to further navigate the data and do further analytics on that space. And this is one of the outcomes of that project where we're able to see the different protocols, the different network protocols, and which IPs were communicating with each other. What was the time when the most communication was happening? Is that expected? Was it not expected? Was it beyond the allowed network communication, and was any protocol being used which was not permitted? So there was a variety of answers that we could come up with in a more visual and straightforward manner than having to look at the packet capture files individually and figure them out. Or even like looking at certain other ways of tabular representation of that data. And once we have that, so using that data, eventual data, there's certain network forensics applications which can be done. So this is something which we haven't done yet, but this is definitely doable. And if there is interest, if you would like to have this type of an application in your context, please reach out to us. So in uh, tying it back to, tying it back to the tactical and strategic way in which you want to do your operations and to be able to meet the mission and vision of your project, or if your um, efforts. In that case, in the network forensic space, in a tactical context, I would say that it is predicting anomalies in current traffic patterns. And then when you see something untoward happening, being able to raise alerts and notifications, and hopefully even before the network fault occurs. And another context is a strategic context, I would say, is that all this data is being generated and you're learning when a particular network fault is occurring. That can be leveraged to learn the patterns and then use it to advantage to raise alarms, which is distinguishing between normal and abnormal network behaviors. And these corrective measures does not have to be manual. It can be automated, because now that you have an idea on the patterns and trends, that can be automated or can be picked up by a machine learning algorithm as it is an operation in your network. Now, what the advantage of this and the strategic outcome of this is that this will let your network engineers to focus more on more important problems which cannot be solved in an automated manner. That is, for example, they can focus on optimizing operations for the scientific applications rather than being on the watch out and looking at is a network fault about to happen. So that type of operational efficiency can be determined. Now, let's move on to one important problem which I think is very relevant to what we are in the scope of discussing at the moment, is that we assume that data is always available and the clean data and the required data is available. But often that is not the case. What happens is a lot of effort goes in trying to find the right data, or sadly, sometimes what happens is the data is available, but we are not aware of it. So the data ops methodology is an effort in that direction to address that problem, where it's trying to get the people, process, and technology, the trifecta, uh, to work together in an optimal manner so that there is continuous improvement in operations which involve data, and to streamline these iterations for continuous improvement. And this in turn enables and accelerates the AI and ML applications, which is which we all want to get at. Now, enterprises struggle to get value from their data just because either they don't know where they exist or there's a certain problem with that. Now, there's an operational gap which is also there often, where the business users and the data stewards and the technical metadata which is maintained in the various databases and data sources, there's an operational gap there. There's manual, error prone, and you won't find the required information you're looking at. And there are different language which is being spoken across these three different entities. For example, the business user is more aware of customer and invoice, wherein the technical in the database and the technical folks will be talking about this particular database table and the data column, data type. So as you can see, there's a language gap which is happening. Now the data ops and the data catalog which comes within that space tries to address that gap, bridge that gap. So data is automatically tagged using business terms, and based on what is already being tagged, that lesson is carried forward. So there could be an AI-driven engine which could help that, and we have one of our products which actually does that. So what is the advantage of that is when you're dealing with large amount of data, having a manual approach of, we would love to talk about more about that. And in terms of the architecture, we had looked at Pentaho, the data integration for feature engineering and data manipulation, and the business analytics for the visualization pieces to get a better understanding. In between, you could have the data catalog, which is called the Limada data catalog, to enable this type of automated tagging, metadata management, and collaboration and crowdsourcing. So these are the different ways in which Limada and Pentaho can be an enabler for the different data projects that you are doing. And there's certain other, definitely lot more which can be done, which I haven't covered as part of this talk. You could do time series analysis, you can do geospatial analytics, social media analytics, and stuff of that nature. And there are a couple of other data products which can enable you in that, or help you meet that mission. So do reach out to us. Please let us know if you have any questions in the virtual booth. We'll be glad to talk to you more about this or anything related that you would like to have more information. We look forward to hear from you at the virtual booth. Thank you. Thank you for your time. Have a great day. Have a great day at the conference.